What kind of project is Skale launched by Coinbase? Yesterday, the exchange Coinbase announced the launch of the Elastic Blockchain Network Skale token SKL. Shortly after the news was sent out, the price of SKL moved. According to data from Bixiobo's official website, the price of SKL has increased by more than 75% in the past 24 hours, with the highest price hitting 65 cents. A record high. So, what is Skale project? Why is it favored by Coinbase? As far as Bixiobo knows, Skale is an elastic sidechain network based on the Ethereum network, mainly to solve the congestion problem of the Ethereum network, and is a powerful player in the expansion solution of the Ethereum network. Overview of Ethereum scaling solutions. According to the official website of Bixiobo, the price of Ethereum has skyrocketed from $100 in the same period last year to $1,800 at present, an increase of 17 times. It also remains high, and the cost of interaction on the chain for a single transaction is as high as tens of dollars, which greatly limits the entry of long-tail users. In order to solve the high fees and congestion problems of Ethereum, many Layer 2 solutions have been proposed in the industry, including state channels, side chains, plasma, rollup, validium, etc. For the concept of Layer 2, interested friends, please check Bixiobo's previous article, What is Layer 2? Read the article Understanding the Investment Opportunities of Ethereum's Expansion Plan. The Skale we mentioned today is one of Layer 2's sidechain projects. Introduction to Skale. Skale is an elastic blockchain network that helps developers run smart contracts with high throughput and extremely low cost. The Skale blockchain can execute sub-second level block times, and the transaction speed exceeds 2,000 transactions per second. It supports smart contracts running in full state, and can support thousands of independent blockchains, elastic sidechains, file storage chains, and other types of child chains, and fully compatible with the entire Ethereum ecosystem. Elasticity means that developers can customize the blockchain according to their needs, which is the biggest highlight of Skale. For example, when selecting the size of the chain, the developer can customize the number of resources of a single node selected to provide security for the chain. Generally speaking, a small chain can choose to occupy 1/128 of the node resources, which can meet the requirements of relatively small chains. Small non-critical dApp needs, while a large chain with a larger user base for higher throughput dApps can choose the parameter that occupies 100% of node resources. At the same time, the number of validator nodes can also be customized. In addition, parameters such as duration, VM, and storage capacity can be flexibly selected. Skale adopts a working token model. That is, when creating a chain, the verifier needs to mortgage a certain amount of Skale tokens. The technical highlights of Skale are as follows. Gas costs are close to zero. No matter how large the network size of Skale is, as long as it is below a certain threshold, its gas fee will be basically zero. Compared with the current outrageously expensive Ethereum mainnet, this is simply not too impressive. Gas being zero is not only conducive to development, but also conducive to market expansion, which perfectly makes up for the shortcomings of the Ethereum mainnet. Random node selection. Skale uses a POS consensus mechanism. How to improve the degree of decentralization of the network under the premise of ensuring high TPS. Skale uses a random node selection and node rotation scheme. Specifically, the verification nodes are not fixed, but rotate regularly and randomly at a certain point in time, after which the original nodes will be automatically removed and new nodes will enter. Virtual child nodes and containerized validators. Each elastic sidechain consists of a set of randomly assigned virtual child nodes running the Skale daemon and the Skale consensus mechanism. By utilizing virtualized child nodes, nodes in the Skale network are not limited to a certain sidechain, but can serve multiple sidechains at the same time. This multi-purpose function is achieved by deploying a containerized subnode architecture to each node in the network. Each node is virtualized while being able to leverage this subnode structure to act as a validator for multiple independent sidechains. BLS rollups. Each sidechain also supports BLS rollups. Rollups in this way provide a more efficient and secure way to use the Scale network to improve throughput and lower Ethereum mainnet gas costs. Rollup is generally defined as a solution in which transactions are published on-chain, but operations and transaction results are stored in different ways, saving gas. BLS rollups compress the size of ETH transactions by utilizing an encryption algorithm called aggregated BLS signatures. Skale token. Skale is the governance token of the Scale network, with a total issuance of 7 billion pieces. According to Bixiobo's official website, the highest public offering price of Skale is only $0.035. The current price of Skale is 60 cents, which is about 16 times higher than the public offering price. 33% of Skale tokens are used for validator rewards, 28% are allocated to delegators, only 4% are reserved by the team, and the rest are allocated to the foundation and the extended basic team. The main functions of Skale tokens are as follows. Pledge. Skale token holders, delegators, stake their Skale to validators who run nodes that make the Scale network work by validating blocks, executing smart contracts, and securing the network, and are rewarded with Skale tokens. Payment method for Scale chain subscription fee. Developers use Skale tokens to purchase subscription access to elastic blockchains, S-chains. Validator rewards. Scale validators earn Skale rewards every time period through decentralized application, dApp fees, network issuance, or token inflation. Governance and voting. Skale will be used for on-chain voting, which will control all economic parameters of Scale network.